Scale It Up Nation, we are professional water treaters, and we need to know what's in the water, and the tools we use to analyze that water needs to be of the top quality. One of the tools that we use are dip slides to determine planktonic bacteria and fungi counts. Fluid Maintenance Solutions provides affordable, reliable, and quality dip slides. Fluid Maintenance Solutions can private label your dip slides with your company logo. Don't leave an empty box behind with your customer. Leave them a branded reminder of you and your company. Order before August 31st and pay only $14.95 per box of 10-count dip slides. Give Fluid Maintenance Solutions a call today at 405-612-7869 or go to scalinguph2o.com/dip slides. Fluid Maintenance Solutions, quality dip slides you can count on. Welcome to Scaling Up H2O, the podcast where we're scaling up on knowledge so we don't scale up our systems. Hello, Scaling Up Nation. Trace Blackmore here, the host of Scaling Up H2O, but I'm not alone today. Normally I do my intro all by myself, but I've invited back one of our most requested guests, and of course, a great friend of mine. So I've got Mark Lewis with me today. How are you, Mark?
Trace, I am doing very well today.
Well, I appreciate you helping me with my introduction. I guess you're going to help me with my outro too. But as far as the introduction, I thought we could talk about a couple of things that were going on. And one that yours truly, have proclaimed August as Legionella Awareness Month. You know what? You and I are going to the same conferences. We're going to the same trainings. And some of the questions that we get from seasoned water treaters, they should be a little further along in their Legionella knowledge than they are. And I'm not saying that to discourage anybody from asking questions. I just don't think that whether you or I or people in the industry, we need to do a bigger push to get people aware of what they need to know about Legionella so they can talk to their customers about it.
Well, Trace, especially with 2020 being the way it is, many things are not normal. And a lot of buildings have shut down, had low occupancy, low water usage. And we need to be sure that when we start bringing people back in, our buildings are ready to receive these people. And so, yes, there's maintenance to the equipment that needs to be done, but there's also awareness of the water that's in these buildings. And so August being Legionella Awareness Month is going to be a great opportunity to showcase some of the things that needs to be done so that we are aware of some of the potential problems.
Yeah, I'm glad you bring up recommissioning or reopening or restarting. I don't even know what we're calling bringing people back into the workforce, but there's so many buildings that are out there that have had very low flow in their plumbing systems. And I had the privilege of working with BOMA this year and doing a presentation on that very topic. And there were very few people on that presentation, on that webinar, that were actually thinking about that. They were thinking about hand sanitizing stations, how many people are going to be in elevators, how are we going to keep the conference room safe? But it doesn't come to the front of mind easily. What are we going to do about these stagnated water systems? And people are going to come back in. So absolutely right. I think we all wish that we were a little further along than we are right now with the COVID crisis, but we're getting through it.
We are.
Well, Mark, another thing that's coming up that I know is dear to me, I know it's dear to you, is the Association of Water Technologies Convention and Expo. And it's a little bit different this year, isn't it?
It is. And Trace, I've been to every convention since 2000, haven't missed a one. And this year I was a little worried. I was like, how are we going to handle this? What's our travel going to be like? What's our social distancing going to be like? And I think it finally got to the point where some better planning had to be done and some decisions had to be made. And so I want to take and thank the board of directors for having to make this call. It's a tough call, but there's just so many things we don't know. So when you add up everything that you know and you make a decision on what's next, I think this decision had to be made, and I think making it at this time allows us to plan for it.
Well, Mark, moreover, the governor actually said that gatherings of 50 people or more were illegal, so they had no choice.
Well, I know there's at least 50 people who come to the convention just to meet and greet with me, and just to make sure I'm doing okay. So that would have been impossible to have.
At least 50 people coming just for you. I want to say we're about 1,200 plus every year when we get together as a convention. So I'm going to have Tom Brandvold on. You, of course, know Tom very well. You used to work for Tom. He's the president of AWT now. And they've done a lot of things because people like you and I, we're going to miss the convention. We're not going to be able to see each other in person. And they want to make sure that they're bringing that experience as well as they can online, where we can still network, we can still see those great papers that are presented, and we can even connect with the vendors that we get to see each and every year. I'm going to have on the show notes page a demo where you can see what they're doing so you can get registered. And here's the thing. AWT has asked people like you and me to get the word out as best as we can because they're trying to add all these bells and whistles to the online convention, but they can only do that if people sign up. So they've lowered the convention registration price. So as I mentioned earlier, we normally have about 1,200 people, but now it's going to be more affordable. It's going to be different, but hopefully more people can attend and you get a taste of what it's like to go to an AWT convention. So maybe instead of 1,200, maybe we'll have 12,000 this year.
We just don't know. The registration fees were lowered to $420 per person for the first two attendees of a company, and these are for membership AWT member fees. And then once you reach two, the third member is only $150. So that's great. It's great savings for multiple people to experience the conference this year.
Yeah, I was speaking to somebody in our mastermind group, and they registered all 25 employees in their company. And he said it was actually less to register everybody in their company this year than it would have been to send 2 employees to the conference because he doesn't have airline, he doesn't have hotel, he doesn't have meals. So think about that when you're making your budget, that you're going to save a whole bunch this year, and maybe you can offer this to many more in your company than you normally are able to.
And it's very flexible as well. We can do it from our home, our office, and attend the sessions that we want to attend, just like if we were there on site.
Mark, a question that I've received from a couple of people is their fellow certified water technologists, and they want to know if they can still receive their certification credits. And the answer is yes, but they're going to track to make sure that you're going to the things that you're supposed to.
Absolutely. You're supposed to, you've got to check into the site all 3 days. So you can't just, log in once and say, oh, I paid my money, and so I'll receive my CEUs. You've got to sign in each day to obtain the CEUs.
Mark, somebody was calling me a couple of months ago, and they were getting very close to their end date for their certified water technologist designation. And they were upset because they were supposed to go to Cleveland this year to get their credits. And of course, as you know, we did not go to Cleveland this year. And that created a bit of a problem for this individual. So my advice with that is never wait to get your credits at the last moment. I mean, who knew that we were going to close the country down? We closed the world down. So I don't think you can ever plan for that. But if there's any advice that we can take from that situation, it's we've got 5 years to do it. Make sure when your 4th year is coming up that you got all your CEs that you need, because you just never know what's going to happen.
Yeah, and I was certification chair for a number of years ago as well. And the committee has continued to make recertifying not easy, but as convenient as possible. We've got a ton of webinars on the AWT website that you can watch. Those are worth 1 CEU. There's for reviewing papers for the convention, it's worth a CEU. And then again, for attending the conference, there's another 5 CEUs right there. So take advantage, review the application as far as what can be done to ensure you've got all of your CEUs to renew that, and don't let it lapse.
And of course, the big one is going to technical training, which we only had 1 this year, and that's 15. It's 5 for the fundamentals and application class that you and I teach. And there's really no reason you shouldn't get your CEU and get it early.
Absolutely.
Well, Mark, I'm glad you're here. I've had a lot of people give me questions either on the website, send me emails, all the ways that people ask me questions on this show. And they want to know about the not so mainstream water treatment methods that are out there. Of course, we've talked a lot about the four issues that water treatment can solve. We should reduce corrosion. We should take care of scaling, microbial fouling, and general dirt and debris. But there are lots of different ways to do that. Normally, we'll talk about chemistries, but that's not the only way to skin that proverbial cat. And I know, Mark, you've got some experience in some of those. So I thought you could come on today and help me help the Scaling Up Nation with some of the questions that they have about some of these lesser known or lesser used technologies.
Trace, I was asked to put together a presentation for mission critical centers with data centers, 7x24 centers that must run all times. And they didn't want just a standard water treatment presentation. So what I put together was a paper called Newer Innovative Technology in Water Treatment Suited for Mission Critical Centers. And so what I did is I backed up and I looked at everything in general that has came out in the last 10 years or so to give people an example of what's out there, because if they've just been exposed to the same old program over and over and over again, well, then they don't know. And so, when you've done this, when you look at the program and what all is available, you got to understand that in mission critical buildings, 33% of their power goes to their HVAC, their chillers. And when you look at buildings themselves, it's I think the number is a little bit lower than that, but I still think it's well over 25% of your utility bill is for your chiller. And so for conditioning your space. So when you're talking about taking care of that, you're talking about a huge portion of your utilities every month. And so what can we do to take care of that? And you're right. We've got to control corrosion, prevent scale, control microbiological growth, and that dirt and debris. We take care of all of that. And by doing that, we are going to ensure our equipment lasts, because not only we want it to run efficiently, we want that equipment to last a long time.
Mark, I remember reading an article almost 20 years ago talking about how the chiller is the piece of equipment that uses the most electricity in any setting. And I guess you could probably test that if you're in some specific process, but definitely in a regular building or the equipment that the light industrial market works on, normally the chiller is one of the largest consumers of electricity. So you're right. If we can make that more efficient, we can definitely reduce our customers' overall energy bill.
And Trace, that I'd love to talk about, and I think you've even adopted it, is the saying that you can't fix a mechanical problem chemically and you can't fix a chemical problem mechanically. And so, if we look at some of our equipment suppliers today, our equipment suppliers have done a great job updating their controllers and pumps and things like that. And so we do need to take a look at what we're doing. What type of equipment are we using to control the program? Because we're not there every day. Our controller constantly monitors the system and it makes changes as it needs. Now, we have controllers that are very inexpensive. You may spend $1,000 for a controller and you have certain items that you can monitor and control. You may say, I want to spend $10,000 for a controller, but you have so many more options and flexibility, and you can really dial that program in, even to the point where it turns on the chemical pump or turns it off, sends you an alarm because of a high connectivity or a low connectivity, a low drum level. You may be running low on a product. It sends you an email. So when that controller communicates back to you, it's like putting another person on site. And we don't always have extra people on site these days. And so when we're looking at these things and what type of equipment we should use, you got to be able to look at and say that we need a little extra help controlling our program because you guys don't have the time to do it.
Back when my father would service water treatment accounts, there were several people assigned to help him. All they did was water treatment. Mark, I don't think you and I have ever seen somebody that just had a water treatment job in one of our accounts. If we have, it's very few and far between. So it's a great point. The controllers that we have there allow us to go home and our programs still be administered. So, Mark, we can go into our controllers by accessing them online, and we can get a lot of valuable data to prepare for us coming out. Or if a customer has a question, we can log in without having to drive across town and give them advice. So, you're exactly right. It definitely helps us help them. And it's like putting a partial person back on site.
And Trace, it's even gotten to these days to where our suppliers are providing cell modems and such that we don't even have to connect through our customers' intranet, internet, so that there's no sense of, oh, you guys are going to be snooping in on what we're doing.
Yeah, that's always a fun conversation. We need access to your network.
But we don't even have to connect to their site. And that technology is out there. And the neat thing is, not only can you look at the connectivity of the water, you can look at the water meter readings. You can install sensors that actually measure PTSA, and that is the amount of treatment that actually is in the system. By measuring the PTSA, you know how much product you have recirculating in the water. You may use a ORP controller to determine your oxidant demand, and that will basically turn on and off a chlorine pump that will help control your biological needs. So controllers are very smart these days, and they are doing real-time adjustments as we're there.
Mark, I received a question not too terribly long ago from the Scaling Up H2O webpage. Somebody wanted to know what PTSA stands for. So for 1,000 points and the lead, paratoluene sulfonic acid. I don't know what good that would ever do anybody, but that's what that stands for. So now you know.
So, Trace, not only can you have sensors that monitor what's going on, sometimes you may not use a sensor, but you can have PosiFlow sensors or flow verification sensors that actually tell the controller that liquid is moving through the pump. So not only did you think it fed, you can verify that it fed. And the one thing that I will say about anytime you have a chemical feed pump, guys, make sure the pump that you're using is compatible with the product that you're pumping. I think that's one of the biggest things is we go in, we look, oh, there's a chemical feed pump, we'll just hook it up, and not realizing that some components are not compatible with some of the products we feed. So take time to evaluate what's there and also make sure that you're using the right pump.
I won't mention any product names, but there's a phosphonium-based biocide that we were one of the first to do some beta testing on, and we had a PVC end, and we thought somebody came in there with a hammer and just broke all the heads.
I've had the exact same thing happen to me.
So make sure you're looking at your compatibility charts. And there's a lot of them on there. I think every manufacturer has a compatibility chart. So that should be the first thing you are looking at before you're ordering a pump.
Absolutely. And the other piece of equipment that can sometimes help solve some problems. For years, we've used solenoid valves, diaphragm valves. You know, we've got these capacitor-driven valves out there these days, spring-loaded valves. And the nice part about those is if you lose power, they're going to close. Now, there again, they are full ported, and they're going to open up, and you get a full stream that's that is utilized for blowdown, and you don't have to worry about those things plugging up. So those are some things that I guess these capacitor-driven valves have been out for 6 or 8 years now, and I may be wrong there, but great little valves. I've used them in lots of applications. I've had a few fail, but there again, if your controller tells you that you've got water flowing and it shouldn't be, you can address that.
One of the best sales calls I was ever on, a gentleman I work with, his name is Chris. We were having some issues with a bunch of debris going into just a regular diaphragm bleed valve. So we were trying to get them to upgrade to a spring actuator valve. And the sales demonstration was Chris grabbed a stick as we were coming in off the street, And he put that stick into the valve and allowed it to close, and it broke the stick and it closed the valve. We sold that valve that day. So sometimes the customers don't know what we're asking them to do, and sometimes we have to demonstrate what we want them to do.
Absolutely. And so understanding what type of equipment you have on site that's going to control this program, regardless of what type of program that you have, is always very important. Having equipment that doesn't function like it's supposed to increases your service time and increases your problems down the road. So, guys, make sure that what you have is working like it should.
Mark, let me ask you this, because I'm sure there are people out there saying, if my customer would pay for the things that we should have there, my life would be a lot easier. So how do we help them? What conversations should they be having with their customers so they do buy maybe some more robust equipment, maybe some more features, and ultimately their customer sees what the payback is?
Well, I think that sooner or later you got to have the conversation that if you're always having to clean something or you're always having to repair something, throw the bug out there that, if we had a better controller, if we had a better valve, if we had a better pump, or we had a compatible pump, we wouldn't be making all these repairs. But just so that every time we have an upset, it's costing you money down the road. And I think in an earlier episode, we actually put value to issues, and whether it's lost water, some fouling indices or fouling percentages, those kind of things. When you talk about real dollars, there again, when you talk about electronic controllers or remote controllers, when we're talking about internet-based controllers, we had just installed a controller at a convention center, and Friday afternoon, about 4 o'clock, we received an alarm. We received a second alarm, and what happened was the makeup solenoid valve stuck open. And when you're dumping 150 to 200 gallons a minute overflow in the tower, and everyone goes home at 4 o'clock. Well, that system would have overflowed all weekend until Monday. We were able to contact them. They were able to bring somebody in, made the repair, and I think it saved them $6,000 to $7,000 just that one time. So it's a great insurance to have. And sometimes that's the way it's, you realize it was the best decision you ever made as soon as it did exactly what it was supposed to do. And so by telling people that, we're not trying to spend money, but we are trying to ensure that we can find things or find problems as quickly as we can.
A little piece of advice that I can give maybe to the newer water treater is don't just put one controller or one piece of equipment there. Something that you can do is have multiple controllers. So essentially, you're kind of bidding against yourself, if you will. You can say, we can go to this basic controller, and this is what it will do. Or we can move up to this medium level controller, and these are the extra things that it can do. And then this high level controller, these are the things that it can do. And by the way, here are all the costs that they can potentially save you if you go with one or the other controllers. A lot of times we have to spell all that out to them.
Absolutely. So we've talked about different types of equipment, and I'm sure there's other types of pumps or valves or controllers or features, but we have talked about some of the newer stuff that's out there and how it works on the mechanical side of controlling our water treatment program. So Trace, why don't we talk about some of the chemistry technology that's out there that is being utilized today that people may not be aware of, or that is just becoming into the market. And I know some of these things, I don't know everything there is about them, and I'm sure you don't either, but we know enough that we know we've got to continue to learn. And I think one of the things that we love to say on this show that is, if you don't know something, don't accept that you don't know it, but it gives you an opportunity to go out and learn some more about it. And our suppliers are just tickled when you pick up the phone and say, hey, let's talk about product X. And I'm sure we're going to have 2 or 3 of those products today in our conversation. So I know several months ago you had Meredy on the show, and she talked about film forming technologies.
Yeah, that was actually about a year ago, Mark. That was episodes 89, 90, and 91.
It was so much information. It took 3 episodes to get that information in. And, one of the things I've used, we've got it at Southeastern, and we utilize in closed water systems and boilers. I have not used it per se in a cooling tower, just haven't had the opportunity, haven't had the experience. but I am looking forward to my first cooling tower episode with Film Forming Technologies because I look at it and it looks so forgiving as long as you maintain your residuals.
Mark, we've been using filming amines for years. Right when they were available for boilers, I think we were one of the first to get in with that, and they have improved quite a bit since that time. Filming amines, we've been able to get them to work in systems where other things would not work. Maybe it was a feed issue or a temperature issue or an equipment issue. Things weren't hooked up right. They gave us the ability to offer another type of treatment that other treatments would have failed. I love to use them in high heat situations. They just work phenomenally well with that. The thing that we learned early on, and I thought that we had failed catastrophically when we used it our very first time, we opened up our very first pail, we pumped it into the boiler, we came back the next day or the day after that, and the water was black and chunky. Oh my gosh, what did we do?
And one of the ways that I love to explain film forming technology is imagine a tadpole with a big mouth on the end. And this tadpole loves to go and bite into surfaces of metal. Now, if it's biting into a chunk of rust, it's going to bite on that rust and hold on. And then you've got this tail out on the end. And as the water passes, it puts pressure and pulls on the tail. And because that rust is weak, it just pulls it off. And another film forming amine is going to bite into the section right next to it. Or if there's scale, because a lot of people don't realize, but calcium is a metal, you're going to bite into the calcium and you're going to pull that off as well. So it's going to clean up your system. And so as it cleans up, and we'll just say the boiler system, then it's carried off to the steam system, and then to the condensate system. And you're looking for a result all the way at the end in the return condensate of a free residual. And all along, you're checking your iron levels and things such as that. But if you are covering up your metal, you eliminate all of your issues that you're going to have there.
Yeah, so Mark, what we learned is exactly what you said. We were overfeeding the product in the beginning. Actually, we weren't. We were feeding it exactly what they told us to feed, but we learned very quickly that that was overfeeding. So, and I shared this on the episode with Meredy, and she confirmed it. What we now do is whatever the parts per million dosage that we're supposed to have in that system, we'll quarter it. And we'll feed 1/4 of what that maximum is supposed to be. And we'll come back a couple of weeks later and we'll increase it another 1/4. And we'll keep doing that until we get up to that 100% level. And we've had far less problems when we've gone low and slow with that. But again, when fed properly, we've had tremendous results with that type of product. And as you mentioned, originally it was just with boilers. Now it's in cooling towers, closed loop systems. Mark, we don't use anything else but amines in our aluminum containing systems. It just works phenomenal for aluminum systems.
I actually introduced filming amines into a system where in less than a year they had some major failures with some molds. And since then, they have fallen in love with the product. When they pull them out, they look just like they did the day they went in. And so it's the customer loves it. And so, when you look at corrosion prevention, because you are actually covering the surface, you got that ion that's biting into the metal and it's protecting the metal. Corrosion can occur. It doesn't create a surface where it can where minerals can stick to it. So it actually does a great job of both the corrosion prevention as well as the scale prevention of the equipment.
Yeah, Mark, you mentioned injection molding, and that is one of my favorite places to use filming amines. I think I've mentioned 5 favorite places, but that's one of them. People don't really treat their molds very well when they take them offline. They're filled with water. They're, who knows what they have in them. Well, if they have a filming amine product in them, they still continue to inhibit a little bit. And I know everybody that's done an injection molding plant, they get all this rust in the system whenever they put those molds back online. I won't say it totally prevents that, but it is so much better.
It does. I mean, it protects the metal. so much better because it actually adheres to the metal. It's not just, most people don't realize, but you've got to have flow for most of our inhibitors to work because you're creating a difference. And because this film forming technology actually bites into the metal, the bond is made that way, not by a charge. And so it's really great the way it works.
I'm going to invite people to go to episodes 89, 90, and 91 to find out all about film forming amines. Meredy Kabari was very gracious in giving us a lot of time on those products. So maybe you should check those out. Mark, I thought we could change topics a little bit and look at solid treatments.
Yeah, Trace, the solid technology there again is nothing new. It may be new to a lot of people, but when you look at the solid water treatment, the best part about the solid chemistry is that you don't have a lot of heavy drums to move, so we don't have to move them around the plant. You also don't have a lot of heavy drums to ship. And so one of the things it does is eliminates hazards on the site because you're taking this solid and you're dissolving it with water from the site and making your reservoir. So as you need it, you're making it. You may have a 10-pound block that is the equivalent to 15 or 20 gallons of wet chemistry. So there again, when we talk about space, we're taking a space of 8 inches by 8 inches by 8 inches instead of a 15 to 20 gallon drum there. And so it's just so much easier to have a box of treatment versus, drums or pails of chemistry around.
Mark, I have to say, my favorite way to deliver product is in the liquid form because I am able to pinpoint it to the exact dosage that I need while I'm there. And I'm just not able to do that as spot on with the solid chemistries. So I think they've gotten a lot better since we've tried them out. In the very beginning, it was very difficult. If it was hot, you might get a one dilution rate. If it was cold, you might get another dilution rate. I think the manufacturers have leveled that out quite a bit. But I'll tell you where I absolutely love solid chemistry is when you have an account where you have to climb up a ladder, go out a hatch, and then walk out on the roof. And, how are you going to carry drums up there? There's absolutely no way. Well, you can put a couple of those solid chemistries in a backpack, very safely go up the ladder, and they are perfect for that situation. So my advice is when you're looking at the account, don't always look at the same way you've always done things. There's all these technologies, and we're going to continue to talk about some more. But does that allow you to do something differently? And maybe that differently is maybe more cost effective, or maybe it is safer, or maybe, like you mentioned, it is not bringing so much product because maybe that's going to put them over on their biocide reporting. Whatever it is, you've got all these things that you can think about that you can provide for your customer, making you a little bit better than some other people.
Absolutely. And the nice thing about all of these technologies is our suppliers love to educate, So if you have questions or you've never used some of these technologies that we're talking about, call your suppliers today and say, hey, let's set up a webinar. Let's set up a time where we can get together and learn about how this works. What's the advantages? How can I sell this? And right now, because our suppliers are kind of limited on being able to go out and see people because of COVID-19, they have the time to do it. So if you've never used solid chemistry, I'd say reach out to some of our suppliers and request a meeting, a webinar, and find out all about it.
Yeah, we've got some suppliers that are in our mastermind group. And just the other day, they were saying, yeah, we would absolutely love to do training because we've got the time right now. That's a great point, Mark.
Absolutely.
Mark, here's the topic that I'm really wanting to talk about because you are probably one of the country's experts on this topic, and it's moss. We're putting moss in water treatment systems, and it's actually working. Tell us about that.
I'd like to take some credit, but back in 2016, in February, Colin Frayne actually did a webinar, New and Greener Water Treatment Technologies through the AWT. And he mentioned moss. And it was kind of interesting. He talked about some of the components and how it worked and some of some of the things that he'd learned about it. He actually went and visited the plant to learn about it. But our introduction, I think, to moss started AWT convention in San Diego. And I forget exactly which year that was. But then right after that, we were introduced at a trial that was in our area. And but the neat thing about moss is that it is sustainable, it's renewable, it regrows and can be reharvested every 5 to 7 years. And then there's multiple purposes after its use. It can be applied to landfills. It can be used as an oil absorbent. It'll absorb 10 times its weight in oil. So if you have other oily applications, you can take used moss and stick it in there, and it will absorb the oil and allow you to treat that system better down the road, maybe more cheaper. Or, it can be compost. It can be put into flower beds or things such as that. So moss has been an interesting technology to get to know and learn and then find out about.
Mark, people ask me all the time when they're trying to review a different type of water treatment program than what they're used to, how do they do that? And I always bring them back to that four-legged stool. The four legs, of course, we talked about them earlier: corrosion control, scale control, microbial control, and control of general dirt and debris. So how does moss do those things?
Okay, so let's go ahead and take the general dirt and debris off the table, because I think all of us would agree that for the most part, the way you're going to remove most of your general dirt and debris through some type of a filtration mechanism. And so we're not going to do that with moss, but you're going to do that with some type of a filtration. I think the easiest place to start here would be mineral deposition. And what people don't understand is that the moss actually absorbs some cations. So your calcium, magnesium, irons, and coppers, it absorbs those and precipitates those. And so therefore it lowers the hardness levels in the water. And then as it absorbs a hardness ion, it releases a hydrogen ion. So if we look at the other three, let's talk about mineral deposit prevention. One of the things that the moss technology does is it acts as an absorbent to cations. So your calcium, your magnesium, irons, and coppers, it's going to absorb those ions and a lot of times precipitate them right to the basin of the cooling tower, depending upon how you're feeding the moss. And whenever it absorbs those cations, it releases a hydrogen ion. So if you add hydrogen to water, what happens? Your alkalinity is going to come down and your pH is going to come down. Well, if you are lowering your hardness levels, you're lowering your alkalinity levels, and you're lowering your pH, you're going to see an LSI reduction or an RSI reduction. So you're going to make the water a little bit more absorbent to those minerals. Now, one of the things that people have to remember is you still have limits on what the moss can do. And what we normally feel like is around 2.2 LSI is about as hard as you want to push it, because you're not adding anything else to the water to help disperse some of these crystal modifiers, or we're not adding crystal modifiers or dispersants. So whatever we're trying to get the water into a point to where it is soluble. And you may say, well, 2.2, that's much lower than what we would ever see before. But because you're lowering your LSI, you're increasing the solubility of water. A lot of times you can increase the concentration ratio of the tower. So just by pulling those minerals out of the water, you're getting what you want from the system. Next, I'll probably look is microbiological. Now, moss is not an EPA registered biocide, and so we will always recommend that you have some type of a registered biocide along with this program. And we have customers who feed chlorine. We have people who feed hydrogen peroxides.
So, Mark, that seems counterintuitive to me, because wouldn't that kill the moss?
We're actually using the leaves of the moss, and they're dead. They are picked off the stems. They're sterilized, and then they're pressed in the briquettes, and that's how we use the moss itself. So that's how we measure how much we're feeding. That's how we know what's going on. So, Trace, what we found is with chlorine levels up to about 4 parts per million, we have no effect on the moss. higher chlorine levels will actually bleach the moss. If you ever go into a moss account and you find the moss is white, you know that it's been bleached. But some of the unique things about the moss, and although we never recommend feeding it alone, we always recommend feeding it with something else. The data shows that we're going to feed about 1/3 or 30% of what we would normally feed under a normal chemistry program. And so I had an account that had 4 cooling towers. I had one. The other 3 were running beside me. And we were maintaining the exact same chlorine residual, free chlorine residual in our tower, and the other 3. But we were feeding 1/3 the chlorine as they were on the other 3 towers. And our ATP numbers were all less than 50 on free and total. And our dip slides would be less than 1,000. Normally they would have 1, maybe 2 dots on them. So very good biological control with that program. So when you look at it, when you think about what's going on, I think you have to refer back to the Smithsonian Magazine article back in May of 2017. And it was entitled, "Europe's Famed Bog Bodies Are Starting to Reveal Their Secrets." And it talks about where these bodies, these people were thrown in these bogs, these moss bogs. And thousands of years later, they're retrieving these bodies and they're perfectly intact. Their skins is, tanned and all. And so when they did the research on it, what they found was that the moss binds the nitrogen. And what that does is it affects the growth of the bacteria. And that's not from me. That's from the Smithsonian Magazine article in 2017. And so it's doing these things, and that has allowed the bodies not to decompose. Now, what they also found with these bodies, their bones were still intact, but they were very flexible. You could move them around, and it's because the moss had absorbed the calcium out of them. So it's there again. Smithsonian Magazine article is May of 2017. Look it up; it's an interesting read. So although we don't make claims about the biological things, and we state that you still need an EPA registered biocide application program to go along with that, that's what we see with the moss program. And as far as corrosion control, one of the things we're doing is because we're not having a lot of, and I like to call them corrosion accelerators added. We're not overfeeding acids. We're tweaking the water to where the pHs are not very high. We've got enough minerals in there to where, as long as we don't have unique situations and, such as low hardness levels, things such as that, we have corrosion rates of 1 to 1.5 on mild steel, and copper are, 0.05 up to about 0.2. The results show us very good control of your corrosion rates in the system. So as far as your dirt and debris, we've kind of said that's separate, but that's mineral deposition, that's microbiological, and that's corrosion control.
Mark, is it fair to say when you were asked to try this on your first account, you were like, this is ridiculous, but I'm being told to try it. I'm going to give it a try and see what happens?
I looked after a moss program for 2 years and still had questions. And probably in order of my acceptance, the scale prevention was first. The way that the program handled the microbiological issues was second. Corrosion control was the third. That was the last thing that I finally accepted in my head as the way that it worked. So the other thing in 2018, my boss, Steve Chuney, did a presentation at the AWT convention, and that article was put into the Analyst shortly after, if you want to go back and read. They've got some pictures, they've got some data.
I'll try to put that on our show notes page, make it easy for people to find. Mark, let me ask, so people can visualize this, how do you put it into a system? How do you feed it?
We have 2 ways to feed it. If we're feeding it into a cooling tower with a basin and we have room, we love to use contact cages, which really looks like a lobster cage. It's got 4 little chambers in it. You open up the top, you drop the moss bags in and close it up, and you set it in an area where there's good flow. And I will say that good flow is critical. You can't put this in an area, a dead leg, or over on the side of a tower. You need to put it over where there's good flow. The second way that it is fed is through what we call a contact chamber. So if you can envision a pool filter the fiberglass round pool filter. We have those that are available in several sizes. The water comes in, circulates around the top, goes down, and then comes out the bottom. And there's baffles in there to keep the moss separated from the nozzles. And so we normally put a flow indicator on there so we can ensure we've got good flow through the contact chamber.
Well, Mark, the next thing I want to talk about are non-chemical devices. And I'm going to leave this one as a bit of a mystery because I'm going to come back later and I am going to do a show just on non-chemical devices. But I'm going to ask the Scaling Up Nation that with non-chemical devices, with anything that you are using to treat the system, you ask, how does it treat those 4 areas? How does it look at corrosion control, scale control, microbial control, and control of dirt and debris? And I think we can all agree typical chemistries don't do anything with dirt and debris. We need to put a mechanical filter on there. But if we don't have that mechanical filter on there, we can't have the other 3. So that's why they go together. So ask yourself, when it comes to non-chemical devices, how do they stack up to your evaluation of those legs? And folks, I want to tell you, they do work, but we'll talk about how we actually evaluate those on another show. Mark, anything you want to add to that?
I think you covered that well. In the last product that I want to talk about, I'm going to leave the name out, but it is a surfactant that can be added to hot water systems and chilled water systems that actually is going to allow the water to absorb more heat. And you may say, well, Mark, how does a product allow water to absorb more heat? Simply by reducing the surface tension of the water and improve the laminar flow. So let's talk about those two. If you've ever seen a mosquito floating on top of the water, the surface tension of the water is such that it can hold the weight of the mosquito. And if you were to put a surfactant in there, that mosquito would sink.
Mark, another thing that you can do is the meniscus. If you have a graduated cylinder and you're trying to figure out how much of a solution that you have, you've got those little tight ends that are pinching together. We call that the meniscus. And of course, we read the bottom of the meniscus on the graduated cylinder. If you put a little drop of soap on that, which is a surfactant, it'll lay down perfectly flat. What it's doing, it's breaking down the water tension.
Well, and the second way that we can absorb more heat is by improving the laminar flow. So as we improve the laminar flow, what we're doing is we're able to get the heat from the edge of the water all the way to the center of the water. So therefore, we have more room for the heat to be in the water. And so by reducing the surface tension and improving the laminar flow, we're able to put more heat from the system into the water. So now we're taking more BTUs back to the chiller.
Mark, I heard somebody say once that the laminar effect, laminar flow, is almost like force fields. So the water's not actually touching the entire pipe. It's lifted up a little bit off of that pipe. And of course, that's where the heat is that we need to transfer. So if we can force that water to lay down onto the pipe, we're going to allow more of that heat to transfer into that water.
Absolutely. And if you ever look under at metal surfaces under a microscope or under some magnified versions, you'll see that it's not as smooth as you think it is. There's a lot of crevices and the water never touches there. By reducing the surface tension of the water, that water is actually laying down and touching all the surface areas of that pipe. And therefore, you're able to pull that heat out of the air and into the water. And vice versa, once you get over into the chiller, what happens there is the water is going to give up that heat easier and the chiller doesn't have to work as hard to get it out of the water. And so, there's been some studies done on this product that in hot water systems, the boiler firing rate, the number of times the boiler fires is actually reduced. Now, this is the easy one to explain because if you can say that I can see that I'm maintaining X temperature of water and my stack temperature is 340 degrees. I know that I'm wasting 340 degrees of heat. However, if I put this product in the water and I'm reducing the surface tension and now maintaining the same temperature, my exhaust gas is only 310 degrees. I'm saving all that, taking all that heat and I'm getting it into the water.
Yeah, heat that you've already paid for, I'm going to add.
Absolutely. So, Trace, if we are improving the laminar flow and reducing the surface tension of the water, we're getting more of the heat that's in the building into the water so that we can take it from the air handlers or the process. We can take it out to the chiller to where it can be removed from the system, or we can take the heat on the boiler system. Instead of pumping that heat up the stack, we can put it into the water. Therefore, it can go out to the building and be used to heat the building. The original intent of what it was, that fuel was purchased for. So when we look at some of these newer technologies, it's out there and we have to investigate them and learn for ourselves.
Yeah, and I think it's important to remember our job is we're heat transfer efficiency managers. What are we going to use to make sure that we're efficiently transferring that heat from point A to point B? And it might be something different than what we normally use. So you and I have talked today some different things that we can use to qualify. Is it better? Is it safer? Is it more economic? What exactly does that better mean? But just like we were talking about with solid chemistry, I'm not carrying 55-gallon drums on my back to get up a ladder. It's a much better choice to use solid chemistry. Well, Mark, it's always fun when you come on Scaling Up H2O. Of course, because of what's going on right now. Of course, you're not in Atlanta today, so we're doing this remotely. A lot of times you just come into the office and start making yourself at home and just start recording on my equipment. But this wasn't one of these days. We actually planned this, and I appreciate you sharing with the Scaling Up Nation what you shared with some of your customers. I especially appreciate you sharing what you've learned over the past few years with Moss.
Well, Trace, I've been in water treatment for 32 years now, and I've seen a lot of things, and I'm sure in the next, I plan on working another 13 to 15 years. And I'm sure we're going to see new modern technologies come out. And I hope to learn about them as well as expanding on what is already out there. I mean, there's so many things that happen to our systems that I think we have to continue to learn about how our technologies work together. So it is fun to be a part of learning and experimenting with and finding new ways to take care of things. And that's what we're out here to do is to treat the systems the best way we can using all of the resources we have. And if we don't know that there's a better way to do it, then we're going to do it the way we've always done it. And there are better ways to do it.
Yeah, you just got to ask yourself a question. Is there a better way of what I'm trying to do right now? But Mark, the most disturbing thing that you just made me realize is we become the old guys. I remember back in the late 90s, early 2000s, when we would go to the AWT convention, there were people much older than us. That was the majority, and we've become the old guys. So thanks for pointing that out.
You're welcome.
Well, Mark, thanks for joining us. Scaling Up Nation, I hope that this interview with Mark has allowed you to think of how could you do things differently? And maybe things aren't broken, but if we keep doing things the exact same way, we're going to keep getting the same results. And wouldn't you rather figure out how you could get better results than having one of your competition come in and telling your customer how they could get them better results? So always push yourself to think outside of the box. And of course, always listen to Scaling Up H2O. See you next week, folks. Scaling Up Nation, on episode 136, you heard from 4 members of the Rising Tide Mastermind. One of those members was Eric Russo. And Eric is an extremely busy individual. And I asked him the question, how he found the time and why he decided to join the Rising Tide Mastermind. Here's what he said.
Like most people in the water treatment industry, there's always a struggle with work and life. And I had a daughter on the way, and I was probably a little more mindful of how much I was working and how I can adjust my schedule or make it in such a way that was sustainable for my family. And this conversation is a little more difficult when you don't have people in the water treatment industry because they don't understand the travel aspect, the service aspect, the technical knowledge needed to be successful. It's a little more difficult to balance that. So to have a group of like-minded individuals to work through with the goal of self-development, it's really helpful to kind of hash through those problems for me.
Have you ever noticed that if you want something done, you give it to a busy person? Why is that? Why do busy people always seem to get something done? And we always wonder why, but there's a secret to that. Most busy people, if they're busy on the right things, it means that they are successful and they've learned to say yes to the things that help with their success, however they define success. Think about that. When was the last time you thought to yourself, how do I define success? Well, those are some of the questions that we ask in the Rising Tide Mastermind. And Eric asked himself, if I join the Rising Tide Mastermind, will this make me a better husband? Will this make me a better father? Will this make me a better water treater? And Eric has told me that it has done all of those things, and he is sure glad that he decided to join. Folks, I cannot say enough good things about being involved in a mastermind group. I ask that you go to scalinguph2o.com/mastermind to see if being a member of the Rising Tide Mastermind is right for you. And if you decide that it is not, please find a group that is right for you. When we get together with other people that are concerned about everyone's success, everyone gets better and the tide rises all boats.